Hello everybody and welcome to today's lesson on standard deviation and z-scores. This is essentially a review of concepts that we have discussed in Algebra 1, and we will expand on that in our next lesson when we talk about the empirical rule. For today, our objectives are: we will identify properties of normal distributions and compare two data sets using standard deviation and z-scores. So let's first remember, what is a standard deviation? Standard deviation is a measure of dispersion. And what that means is it measures how spread out the data is around the mean. A dataset standard deviation can be calculated using our calculator. For the standard deviation, let's remember the symbol is the lowercase Greek sigma, which kind of looks like an O, but it has that extra squiggle there on the top. Let's try an example right away. Find the mean and the standard deviation for the following data set. As I said, we do this on the calculator, and let's follow these instructions step by step. First, we press stat 1, and that will send us into the table where we can then input our data. Put the data in. The order doesn't matter. 4, 9, 11, 12, 17, 5, 8, 12, and 14. When we're done putting the data into the table, we press stat again, go over to calc, and press 1. And depending on the operating system of your calculator, you have to just keep going all the way down to calculate, press enter, and that will give you a number of various statistics. The two important ones we need here for today are x bar, that's your mean, and further down we get sigma x, that is your standard deviation. So let's write down the numbers we found. In statistics, we very often do that with 3 decimals, so 10.222 and 3.938. A z-score of a particular data point is the measure of how many standard deviations that point is away from the mean. So what we're doing is essentially we use the z-score to measure how far is one particular data point away from the mean. Is that unusual compared to other data points in that set or not? And we also use it to compare two different data sets, which most likely have different standard deviations, but by using the z-score, we compare them on a normalized basis. Let's look at our example. If a data point is 2.5 standard deviations above the mean, what is its z-score? Well, 2.5 standard deviations above means that the z-score is positive 2.5. And if that's the case, what value would that be for the data above? In the data above, we had a mean of 10.222, and now we have a point that is above, so plus 2.5 times 3.938, and that is equal to 20.067. On the other hand, if a data point is 1.5 standard deviations below the mean, what is its z-score? It will then be negative 1.5. And what value would that be for the data above? Let's look at this again. 10.222, which is our mean, and this time minus 1.5 times the standard deviation of 3.938, and that will be equal to 4.315. The formula for the z-score is z is equal to x minus mu divided by sigma. And so what do all these symbols mean? Mu stands for the mean or average for a data set, and sometimes we're using mu, sometimes, just like the previous page, we use x bar. You will also see that very often, and these are just two different symbols that mean exactly the same thing. Our Greek sigma stands for the standard deviation, and our x in this case is one individual data point. Data point or data element. Those are the words that you may see being used for this. A data point is said to be statistically unusual if its z-score is more than 2 standard deviations above or below the mean. Let's look at our example here. Kelly's test score on the rational equations exam was 95. If the class average was 78 and the standard deviation is 5, determine if Kelly's score is unusual. Using a formula from up here, we can say that the z-score of Kelly's exam is 95, which was her exam grade, minus the average, which is 78, divided by the standard deviation of 5. 95 divided by 78 is 17. Divided by 5, we get 3.4. Now 3.4 is way above 2. So we can say, yes, Kelly's test score is unusual. And it is unusually good, in fact. So well done, Kelly. Let's look at this next example. Suppose our friend receives an 80% on a test in AP World History and a 90% on a test in underwater basket weaving. Interesting choice there. The average score on the AP World History was 72 with a standard deviation of 6.5, and the average score on the underwater basket weaving test was an 88% with a standard deviation of 3. Statistically, which test score is better? What we are trying to do here is we're trying to find the z-scores of the two different test results of our friend and compare them and see which one is further away from the mean and therefore better. So let's find our z-score for AP World History. It'll be 80, which was the test score, minus 72, which was the average, divided by 6.5. And punching that into the calculator, we get approximately 1.23. And in underwater basket weaving, he or she got a test score of 90. The average or mean was 88, and the standard deviation was 3. So 90 minus 88 is 2 divided by 3, or approximately 0.67. So we can say the score in AP World History was better statistically because it was higher above the mean than the test score in underwater basket weaving. Now that is because both z-scores were positive. If the z-scores are negative, that means that the test score was below the average, and then of course the one that's further away is the worst one. Alright, let's move on to our last example. You have a normal distribution with a mean mu of 235.7 and a standard deviation of 41.58. Which data point has a z-score of negative 3.45? Here we're supposed to use that same formula, but this time we're not looking for the z-score, we're looking for the data point. So we have to plug in our numbers and then solve our equation for x. Negative 3.45 is our z-score, and that is equal to our data point minus the mean, 235.7, divided by the standard deviation of 41.58. In order to solve this for x, we are first going to multiply both sides by 41.58 because we want to get rid of our fraction. That cancels out on the right, and on the left we get negative 143.451, which is equal to x minus 235.7. And now let's add 235.7 to both sides. And we get 92.249 is equal to x. That is the data point that has a z-score of negative 3.45, which is way below the mean. So our data point is 92 compared to a mean of 235.7. All right, you guys, that's it for today, and I will see you in class.